Till now, we have discussed one type of multiplication of two vectors, correct? That is, we discussed about the scalar or dot product. Now we'll look into another one, which is the vector product, or you can also call it as the cross product or vector product. This is the next type. Now, again, you have studied about this, you have done problems on this, but still it's more like a revision, or you can say it's more of a little more detailed discussion about the cross product. Now, whenever we have two vectors, say you have vector A and vector B. Now, the cross product between the two vectors, that is vector A cross vector B. Whenever we do this, what we are going to get, the result is going to be mod of A into mod of B into sine theta into n cap. Now, whenever we do this, remember this part, that is this part is the magnitude. Okay, magnitude of that particular vector, product of the vectors. And then this part gives us the direction. So this comes to or we can conclude that the cross product between the two vectors is a vector. That's why this is called as a vector product between the two things. Now, how do we determine the direction of the two vectors? Okay, direction. See, very simple. Assume that this is vector A. Assume that this is vector B. Now, when you're doing A cross B, A comes first. So from A to B, you move from A, you move to B. So what you do, you curl the fingers like this. You're moving from A to B. See the direction of the thumb finger? The thumb finger goes up, correct? So whenever we have A to B, A cross B, this is the direction. Suppose say we do B cross A. Now what do? You are starting from B. So B is here. So from B, you move to A. So when you go from B to A, the direction is downwards. So A cross B and B cross A, if you look at it this way, the direction we can calculate of the cross product with the help of this right hand thumb rule. You take this, you rotate. This is the direction. Or also we can call it as the screw rule. Okay, so these two rules, they help us in getting to know the direction of the cross product, that is A cross B. Suppose say you have assume that say this is vector A, say assume that this is vector B. Now remember, we are going from A to B, correct? The resultant is going to be in this particular direction. This is A cross B. Okay, so you're going from A to B, so the direction is upwards. That means the cross product or vector product between any two vectors is always perpendicular to the plane containing the two vectors. That means if vector A and vector B are in xy plane, then the cross product between these two is going to be along the z axis, which is perpendicular to the xy plane. Clear? So, since you know what is the cross product, we'll look into certain properties and observations with respect to the cross product. The first observation, a very important one, is that the result is going to be a vector, which we already know. Correct? That's why that n cap, the direction part, comes into play. Fine? This is the first one. The second one is that whenever we have two vectors, let's say those two vectors are parallel to each other. Okay, that means let's say this is one vector which is vector A, say this is one more vector, vector B. Now here, if they're parallel or if they're collinear or if they're anti-parallel, like it could be like this also, anti-parallel. In all these cases, the cross product becomes 0. The reason is, see, whenever if two vectors are parallel or collinear, then theta value is 0 degree. For anti-parallel, theta is 180. Whether it is sine 0 or sine 180, the value is 0 itself. So A cross B becomes 0. A cross B becomes 0. Clear? This is the next one. The third one, we are going to have maximum value of the cross product when theta becomes 90. Sin 90 is 1, right? So when you have A cross B, the maximum value is going to become mod of A into mod of B into n cap. We can't just write mod A into mod B, not like a scalar product. We have to have that n cap character. Fine? So mod of A, this is when theta is equal to 90, or you can say pi by 2. Okay, in the second case, when theta is 0 or 180, it's going to be 0. Here, when the theta is pi by 2, we have the maximum value. Suppose if theta becomes 3 pi by 2, then you will have maximum, but in the opposite direction. Okay. Now, the fourth property, or you can say fourth characteristic of a cross product. Suppose say we have two vectors, vector A, or rather than taking vector A and vector B, let's start with the most basic, that is I, J and K. Alright, suppose say you have I cross I. I cross I is going to become 0, same direction, correct? So I cross I, J cross J is also 0, K cross K is also equal to 0. Now these three are zeros. But what if we have I cross J? That means here we are looking at I cross J. This value becomes K. Think about it. I is in the x-axis. J is in the y-axis. Whenever we take the cross product of these two, we have to get something which is perpendicular to both x-axis as well as y-axis. And what is that? Z-axis. So x cross y gives us z-axis. Okay, x cross y gives us z. That means here we go in a cycle. J cross k becomes, or J cross k gives us I, K cross I gives us J. So for that we have a cycle in which it goes. We look into that cycle now. Now what we have is, see, this is I, this is J, this is K. Now first thing, what do we have? When you do I cross J, what does it give you? K. Next, so I cross J will give you K. The next one, when you do J cross K, this gives you I, correct? And then suppose if you do K cross I, that gives you J. Clear? So this is the case. That means we have to go in the anti-clockwise direction. So we are going to get a positive value. Suppose if you do the same thing in the other way around, that is I, J, K. Now if you do J cross I, you're not going to get K. Instead, you will get minus K. Okay, and same thing, I cross K will give you minus J, K cross J will give you minus I. That means here J cross I is minus K. Next, K cross J gives you minus I. Then you have I cross K gives you minus J. Clear? This is extremely important whenever we do the expansion of the, the two matrices multiplication. Whenever we do this, when you expand it as a determinant, this particular way is very important. Clear? Now, how do we find the angle? The next observation what we can talk about. In the next one, what you have is, suppose sine theta you want. Then we do vector A cross vector B by mod of A into mod of B. This gives us the angle between the two vectors. Fine. Now, how do we expand the vector? This is very important, which you guys already know using the determinants. Fine. Now we look into how do we expand the cross product. Now in this case, vector A cross vector B, this becomes, take the determinant I, J, K. Now vector A can be split into its components, correct? So let's call this as AX, AY, AZ, BX, BY, pz. Now that you know how do we expand the determinant, use the expansion of determinant, find the value of A cross B. Clear? Now the next one, what is the geometrical meaning of this A cross B, which is very, very important. Suppose if you have two vectors, vector A cross vector B, which are co-initial vectors. In the sense, suppose say this is vector A, OA, say this is vector A, and we have another value, let's say something like this. Say this is vector B. Now, what is the geometrical meaning of this cross product of two vectors? Now, here, if you complete this, this becomes a parallelogram, correct? Now, to find the area of this particular parallelogram, we use the cross product of two vectors. In the sense, vector A cross vector B. Take the modulus of that vector A cross vector B. This gives the area of parallelogram. Parallelogram of what? Parallelogram having vector A and vector B as the sides of the parallelogram. That parallelogram area is given by mod of vector A cross vector B. Now, since we know the area of parallelogram, we can also find the area of the triangle, correct? Area of triangle is what? Half of the area of parallelogram. That means if you need the area of the triangle with vector A and vector B as the sides of the triangle, then the area can be calculated. So, area of triangle is equal to half to mod of vector A cross vector B. This gives us the area of the triangle. Area of parallelogram we know, half of that gives us the area of the triangle. Clear? Now that we know, we have understood certain basic observations and certain basic properties of cross product. Now, is it commutative? Is it associative? We're not going to talk about associative, but is it commutative? We'll look into those things now. First, very important property, is it commutative? Is it commutative or not? This is the first one. Answer is no, it's not. Because here, when you do A cross B, guys, think about it. This is A, this is B. A cross B, when we do, it goes up. But when you do B cross A, same thing is going down. So in vectors, direction is very, very important. That means whenever we do A cross B, this is equal to minus of B cross A. In the sense, it is not commutative. Let me be very, very, very specific. The cross product is not commutative. Okay, this is a very, very, very important point. It is not commutative. The second one, what we are going to look at is distributive. Okay, so is it distributive over addition? Yes, it is distributive. In the sense, suppose if you have vector A cross vector B plus vector C, we can write this as vector A cross vector B plus vector A cross vector C. It is distributive over addition. Clear? The third one is, what if we multiply by a scalar? Scalar multiplication. Scalar multiplication in the sense, suppose if you have lambda into A cross B, this is equal to lambda into A cross B, this is one, or lambda, sorry, not lambda, just A cross lambda into B, or A cross B whole thing into lambda. All these are true. Okay, so in a vector multiplication, or you can say in a cross product of two vectors, Remember one thing, it is a vector quantity. It's not commutative. Okay, and then if you have to find the vector product between two vectors, use determinant. Fine. And if you want to calculate what is the vector which is perpendicular to both the vectors, that's nothing but a cross product. Okay. Now, these are certain basic properties and observations on cross product, and certain properties also like commutative, distributive, and everything. Now, this completes the vector product between the two vectors. Fine. In the next video, we'll solve few problems based on this one. And along with that, we'll be looking into another concept called direction cosines in the next video.